Right, in this video, we're going to take our best performing algorithm, the nearest neighbor, and apply it to a near real-time data stream. So let's go ahead and get started. This will be a little bit more complicated than in the regression case, simply because displaying binary classifications require different styles of visualization. So we're going to have many of the same packages we've used in the past, but there are a couple of things that we'll need to just have you copy into your notebook. So these lines, first and foremost, we need to declare this as a matplotlib notebook. This will allow for our interactive visualizations. The pyplot as PLT, we use this all the time. Matplotlib ticker, this will be a little new. This will help us to format our tables or our figures. And then this is critical. So this will disable the warnings just like we did last time, so that we don't have a warning about the insecurity of our request coming back every single loop of our while. Just like before, we're going to have our current time, so that's not going to change. And then, so now we want to define the data that we're going to kind of record every single iteration. So let's go ahead and define those with our column names. So we'll call these, just like before, timestamp. If it is truly busy or not, so that's going to be a binary 1 or 0. The estimate of if it's busy, and that will be our estimated value. 1 or 0 again, and then the estimated the probability that it is busy. Now we won't have things like accuracy or MAE here. We could record those if we wanted to, but for this particular instance, we'll just kind of visualize the current performance of our model. Now let's go ahead and build our data frame, and this is the data frame that we'll use to record the data every single minute of data that comes in. Now we're actually going to have to start defining our figure. So this is going to be very similar to what we did last time. First, we're defining our plot. Now, in this case, we're going to do something a little bit different. We're going to be overlaying two plots on top of one another. One is going to be a bar chart, and one is going to be a line. So that's why we're using this subplots. We set the size. We have to go ahead and define it as a show. We have to have something to draw on to start with. Legend draw and first run, we'll use these in a moment. Just note that they start at 0. End time, so this is the final time that we want to do anything with, and we can adjust this later. The time step, so how many minutes are we going to request data for? Set y ticks, so this is for one of our y axes where we want to actually put the ticks, and you'll see this in a second. Similarly here, the labels for those. And then here, the AX2, this is for the secondary axis. And again, I'll explain kind of what all of these are doing in a moment, but this is essentially going to be one of these axes is going to be the probability that our algorithm is predicting the camera is seeing a busy environment. The other will be if it's true or not. So let's go ahead and start our while loop. Essentially what we want to do is we want to, the very first time it runs, define what minute we're starting on, because then after that, we're just going to add this number 30 every single time. So we only need to establish what time we're starting at the first run. So to do that, it's pretty straightforward. What this is going to do is this will go in and it will say, okay, for this one row, this first row, the current minute is equal to this. So we're going to just calculate the actual current minute. And this has to do with the hour that it is in the minute. And then the timestamp itself is going to equal to that minute as the type float. And that way we can add the number 30 or the number 30.0 to it every single time. And then we're done with that. At the very end now, what this will ultimately enable is this. We can now say, okay, timestamp equals timestamp plus timestamp min. And this will let us establish what the current timestamp is every single time. In most cases that are not the first run, we won't need this. But in the first run, we have to establish this. So, and we'll actually put this ultimately right here. So the first run, this will be overwritten, because it won't be defined. So we'll actually have up here, we can do, for example, timestamp equals 0, just to start with something. So here, the first time that we run this, it'll be timestamp equals 0 plus 30, but then we'll immediately overwrite that here. And then after the first one, we won't use that anymore. The next thing that we have to do is actually start to program our algorithm. So now we just have our basic loop here. Just for the sake of testing this, I'm actually going to change this so our end time is a very, very early end time. So we'll start, for example, at 0, 1, 59. So this will be a very, we should only get at 30-minute time steps about 4 iterations. So we'll go ahead and there we go. So now we can see down here, we've got a few different iterations of our timestamp coming out. So that will iterate until we have the current time is less than the end time. Now, right now, this is going to keep going and going and going and going and going because we have no stop condition currently applied in our while loop. So we'll go ahead and write that in now. So let's stop this. And we'll go up here. And all we're going to do is we're going to say, okay, at the very end of the while loop, we need to set current time equal to current time plus the time delta. So this is the difference that we are declaring in our time step. So this is just saying add 30 minutes in this case because time step min is 30, and this is time step minutes. So 30 minutes, and we're saying add 30 minutes to the current time. So when we run this time, we should only get a small number of loops in the while loop, and then it will essentially end. Minutes. All right, yeah. Let's try that one more time, but this time with the correct end date, which is the 1st of September, not the 3rd of September. So we'll run that one more time, and this should end just after a few loops. There we go. So 0, 30, 69, right? So we're only going a few different loops because we have, our end time is 1:59, our start time is midnight on the 1st, and then we're adding 30 minutes each time. So that'll be a very quick way to test if this is working. Okay, so now we need to start actually modeling within each time step. So let's go ahead and delete this print. And let's start just kind of adding in elements of our model. So the first thing that we'll have to do is we'll have to define if it was truly busy or not. And this is the same thing we did earlier in our code. So I'm just going to copy and paste it. This is just saying take the person count, see if it's greater than 30. If it is, it's going to be a 1. Otherwise, it's going to be a 0. That's what the as type int will do. So now we'll have truly busy every single time. We also need to clean up our data. So this is going to be the exact same thing we did earlier in our code. We're just going to remove all of the columns of data that we're not using. The next thing that we have to do is a scaling. So you'll remember that our CNN10 and our image brightness, we do apply a scaler to those. So we'll have to do the same thing here. We have the scaling model we actually already used. We want to define scaled X, and all we're going to do is apply the scaling model to CNN10 and ImageBright. The .values.reshape, this is just necessary in order to get the data into the format that we need. If you're interested in exactly what that's doing, you can always copy this entire line right here and then put it into another cell and see what this is actually doing. The next thing that we're going to do is we're actually going to create our estimate. So now we have everything we need. We've got if it's truly busy or not, we have the timestamp, we have the estimate of if it's busy, and the probability. Let's save all of that into our data frame that will be updated every minute. And then let's just go ahead and print this out to take a look. And here we go. So you'll see over time, we have our estimates, if it was truly busy or not, and our probabilities. So these first 3, right, from midnight to 1 in the morning, are all zeros. So there's no, our models are not suggesting that it's busy at that time. So now we have our kind of real-time modeling happening, and the next thing we want to do is actually create the visualization for those. So to do that, there's a couple of things that we'll need to do. First, we actually want to define how our X ticks. So these down here are going to be using the dates so we can see over time how things are changing. So that's pretty straightforward. So what this is doing here is this is saying define my X ticks. There's going to be this many ticks, which is going to be the length of our data frame. So every single time we get more data, the number of ticks will increase, and then name them this. So we're going to name them based on our timestamps. The next thing that we'll need to do is we need to tell it what the y-axis is going to be. So that's going to be, for us, we really want to do the predicted probabilities. So what this does is this actually gives us the y-axis, and all we're with this multiple locator 1 just means that we want the step to be 1. So our y-axis will be from 0 to 1, indicating the probability that our model ascribes to the minute being a busy minute or not. The next thing we want, let's go ahead and add a grid just to make things look a little bit more interpretable. So that adds a grid. That's pretty straightforward. And then the next thing is we're actually going to plot our probability that things are busy. At this point, we can see there's a couple of problems. First, we are getting data, right? So we are predicting our probabilities. They're all zeros still, so we just have a straight line. You can see down here, the way that our x-axis ticks are being allocated is incorrect. They're all kind of down here clustered. And the reason for that is there's a discrepancy between how many ticks we're defining and the number of data points that are coming into the model. So we need to do a little bit of work to fix that. So the first thing that we're going to do is up here, we have our plot.xticks defined. We're then going to redefine our axis. And we're going to do that based on how many ticks we've seen so far. So for example, for the first 25 minutes, we might want to show every minute. For the next 50 minutes, we might only want to show every 120 minutes, one tick, because at some point there are so many ticks you can't see anything. So I'm just going to copy and paste a few lines of code here. And so what these do is it says, okay, if you are under the 25th minute, then we want every 30 minutes to show a tick. If you are after the 25th minute, or the 25th time that we've retrieved information, then we want to show every 120 minutes. If it's after the 100th time that we've retrieved information, we want to show every 360 minutes. So depending on what your time step is, so right now our time step is 30 minutes. So that means every single entry into pred data frame is representative of 30 minutes. So this is saying for the first 25 entries, which are all representative of 30 minutes, show every single one of them. After that, start showing only every 4. So we're basically rearranging our xticks. So go ahead and run this. And now you can see at the bottom, right, these xticks are kind of more dynamically being visualized. So the 30th minute, we have 0% chance, 60th, 0%, 90, 0%. Let's go ahead and set this up so we're pinging a little bit more. So our end time, let's go ahead and set this to 23:59. So this is going to go through the first day of the data that we have. We'll go ahead and run this. And there you can start to see some of these probabilities, right? So what we're saying is that in the 450th minute, or of the day, this is around this probability, around 80% probability that it's busy. Now, what this is not giving us is what the truth is. So we do want to have some indication of how well our model is performing over time. So let's go ahead and add that into this chart. So I'm going to stop this, and all we're going to do is we're going to superimpose over this chart a bar chart, and that bar chart will be 0 in cases where it's not busy, and it will be 1 in cases when it is busy. So we'll go ahead and add that in. We'll add that in right here. So plt.bar. Okay, and there we go. So this is pretty straightforward. We're going to have the time is our x-axis for the bar chart. The height is going to be, if it's truly busy or not, a 1 or a 0. The width is 30 because we are doing 30-minute increments, and the color is blue. You can set that to whatever you want. And that's it. So we'll go ahead and run this. And what we'll see is over time, so this is our model estimates. And there we go. So this is the first minute where it is truly busy. And so you can see our model over time is, we're pretty good. We're getting some misclassifications. So like this spot right here is an area, this kind of white empty area right here. This is when our model was predicting an 80% probability that it was busy, but it was not. Similarly, right here, we have nearly a 90% probability, but it was not busy. Here, a 20% probability it's busy, but it was busy. So our model is certainly not perfect. But we do see these kind of general trends of when it is busy, we seem to be doing a reasonable job. So this was the first day of the data. So let's actually go and let's go through the full time series. So I've changed this to 9.3. And so we're going to go from 9.1 to 9.3. And we'll go ahead and run this, and I'll let you guys be serenaded by a beautiful musical outro as we watch this script perform.